Hey, Sunshines. So we are going to prove that these two triangles are congruent using the information that's given to us. So I have our little cheat sheet of how to prove that two triangles are congruent as kind of reminders. So step one is to look at your given information. Nothing in our given information is a simple congruent statement. They're all pieces that we're going to use to find that stuff is congruent, but it's okay. This is still going to be enough information. So it says step 1, 2, 3, 4, but really the order doesn't matter. I would always start with the given information because that's the easiest. But you can look for all of these. So first of all, we're given that segment SA bisects angle CST. So bisectors and midpoints create pairs of congruent pieces. So angle CST is this angle here up top. So if SA is bisecting it, that means it's cutting it into two congruent pieces. So this angle and this angle are congruent to each other. So my next statement, anytime I have something bisect something, my next statement should be the two pieces that are congruent by definition of bisector. Now, in this case, it was an angle that got bisected, so I'm going to say definition of angle bisector. So now I have one piece that's congruent. I have an actual statement. I have an angle that's congruent to an angle. So that's going to be one of my pieces because I'm going to need, I don't know which of my 5 shortcuts I'm going to use, but I know I'm going to need one of those. So I also know that two segments are perpendicular. Perpendicular lines are going to form right angles, which probably should be in this list, but I didn't think of it. There's a lot of things that you can look at, but anytime you see perpendicular lines, you know that's going to form a pair of right angles. So segment SA is perpendicular to segment CT. So that means these two angles here are both right angles. So these two angles are right angles. That is the definition of perpendicular. Perpendicular means that they intersect to form right angles. So your reason is definition of perpendicular. This is a little bit awkward when you're given perpendicular lines. It tells you that they're right angles. Then it's actually a separate step to say that the angles are congruent because all right angles are congruent. Depending on which of the 5 shortcuts you use, for these 4, you need to state that the angles are congruent. For HL, you need to just state that they are right angles. In this case, I know I'm not using HL because hypotenuse and leg are both sides and I already have an angle pair. So if I have a second angle, I know I'm going to be using one of these. I know I'm not using the ones that are the ones that have at least 2 sides, because now I have information about 2 angles, so I know I need one of the ones that's information about 2 angles. So in this case, I know I'm going to need that other statement to say that, let's zoom this so there's a little more space. So all right angles are congruent is one of those it's one of those rules that we're allowed to say. It's just one of those postulates. The definition of a right angle is that it is an angle that is 90 degrees, all 90, so if it measures 90 degrees, then they're all congruent. They have the same measure, so you just say it this way. All right angles are congruent. You can write out the word right, you can write out the word angles, you could write out the word congruent, but obviously the more you abbreviate things with symbols, the less space it takes up. So now I've used that, and I've used that. So now I need to look for another piece because I have 2 congruent statements in here so far. I've got 2 pairs of angles. So I need to find a pair of sides because angle is not a thing. It's a thing for similarity, but it's not a thing for congruence. You need to have a pair of sides to give you a frame of reference that the triangles are actually the same size as each other. So now I need to look at my little list and see where I can find some help. If I have the triangle sharing a side, that's going to give me a pair of sides because segment SA is a side in both of the triangles, and it's going to be congruent to itself by the reflexive property. So now I have 3 pieces that are congruent. I have 2 pairs of angles and 1 pair of sides. That could still be either of these. I have to be careful about what order they go in. I have to actually go back and look at the triangles and say, okay, so I've got an angle over here, an angle over here, and then the side that's congruent is connecting them. So that means it's angle, side, angle. So the order really matters. Angle, angle, side would be if I had like this angle instead of this angle, then I would have angle, angle, side because the side would be not the one that's connecting them. Or if I just had a different pair of sides for whatever reason. So now I can finally say the triangle is congruent to the triangle by angle, side, angle. And now I'm finished with my proof because I finally said this statement and gave it a reason.